Okay. I'm going to sketch these two lines. Okay. And of course, we got to have values for C and D. So let's just say, in my case, numbers are okay, 3x plus I'll call it 8y equals 12. And let's say we've got 5x minus 4y equals 8. Okay, so we graph. Okay, well, we can find the intercept pretty easily. And I'm going to have room to do a graph down here. I'm going to draw a graph. I'm not going to put a scale on it until I know what my intercepts are, so I know how big of a scale I'm going to need. Because once I know where my intercepts are, I've got a pretty good idea then where the lines are going to intersect. And I can get everything on the graph, and the graph will be big enough that I can make decent estimates, I hope. Okay, so get this, 3 times 0 plus 8y equals 12, which just means 8y equals 12, so the y equals, well, it's going to be 3 halves. And let's just do the y-intercept of the second equation, okay? If x is 0, y equals negative 5 halves, which is negative 4.5, right? And we're going to want the 4.5 so we can plot. Okay. If y equals 0, so these are your x-intercepts. Y-intercepts. So this equation, first equation, and this equivalent to the second equation. Okay. Your x-intercepts occur with y-0. You get 3x plus 8 times 0 equals 12, so it actually equals 4, right? Down here, you get 5x minus 4 times 0 equals 18. And you get x equals 18 over 5, which is 3 3/5, which I'm going to write as 3.6 because that's kind of convenient. Okay. Now, I tried to write these out so that they don't interfere with my graphs. I don't know if I've been successful. I wasn't thinking that, I wasn't thinking that clearly, but let's see. Okay, the y-intercept here is 3 halves, right? And this is for the first equation. So you have a point where x is 0 and y is 3 halves, right? Okay. If x is 0, y is 3 halves. That gives you 0, 3 halves. Well, let's stop for a minute and think how we're going to scale this. Okay. Our y-intercepts are 3 halves and negative 4.5. I'm going to have negative 4.5 on the y-axis. I'm going to put negative 4 here. Negative 4.5 will be a little below negative 4, and just see how far below. We can subdivide the interval from 0 to negative 4.5, and then subdivide each of these in half, and we get units. Not particularly accurate, but they'll do. And then I'm going to divide this interval from 0 to -1, because here's -1. Going to divide that in half, so we see where half is. So we go this far below -4, and right here would be 0, -4.5, right? Okay, so everybody, let's make sure everybody understands this, because there's a little confusion on the idea, and this doggone thing keeps re-zooming itself. Now, I don't mean starting over, I mean it changes the zoom when I'm not looking. Okay, so there's a little clearer picture of the board. But I'm going to pause for a second. We can talk about this to make sure everybody understands. Okay, let me a little more quickly repeat a little what I just said. We plug 0 into the second equation, and we found that y has to be -4.5. Meaning, if x is 0 and y is -4.5, this equation is satisfied. That means the point 0, -4.5 is on the graph. It's an intercept, because the intercepts are easy to find in most cases. That's a useful way to graph. Sometimes you're really close to the origin, it's a little hard to do the graph, you got to use the slope. Okay. But there we have it. There's the y-intercept of the second equation. So let's go ahead and do the x-intercept of the second equation. Now, here's where we use y equals 0 in the second equation. And we found if y is 0, x has to be 3.6. Okay. Now, up here, for the other equation, we found the x-intercept was 4. So we're pretty safe. Using the scale here, or the x coordinate is 4. Then we can subdivide that to get 1, 2, and 3. Then the second equation, our intercept is going to be at 3.6. So we have point 3.60. So now we can sketch a straight line through these points, and right here is the graph of our second equation. So this is the graph of 5x minus 4y equals 18. Graph the second equation. You might not be able to read all of that, but you know what it says. It identifies this as the graph of this equation. Okay, well, I want to get the graph of this equation. Well, the y-intercept is 3/2, right? When x is 0, y is 3/2. Put 0 here and 0 in here and 3/2 here. It satisfies the equation. So I know that's a point on the graph of the function. Now, I've already set the scale down here. 4 is this big, so 4 has to be up here. And 2 is going to go, well, a little longer than that. I think. A little hard to see from this angle. My different part of the block, but there we go. Okay. So there's 1, there's 2, 3/2 is 1.5. So here's the point. 0, 3/2. Then the x-intercept is 4. Okay, which means we have the point 4, 0. I'll go into detail on explaining that, because it should be pretty obvious. And there's my approximate straight line. Okay. Now, we can estimate the coordinates of this point. But there's the x coordinate. It's pretty close to 0. And here's 1, here's 0, here's 1/2. We say that's maybe 0.2 or 0.3. I'll fudge and say 0.25. Okay, so x is 0.25, so the x coordinate of this point is 0.25, and the y coordinate well, this is 3.6. It's a little more than 3.6. Maybe it's 3.7. Maybe it's 3.8. So I'll flip a coin and say, okay, 3.7. That's at x of 0.25. This is y, obviously, it's on the y-axis. So x here approximately equals 3.7. This is approximately equal to, okay? So now our point of intersection is 3.7.25. Well, now I plug these numbers back into the equation. Things get a little crowded here, so I'm going to go all the way over here. If I can't see that much of the board. Okay, I'm going to come all the way over here and do that. So we have, again, 2x plus 8y is 12, 5x minus 4y equals 18. Again, x equals 3.7. Y equals 0.25. Equation, we get 3 times 3.7 plus 8 times 0.25 equals 12. Well, 3.7 is 11.1, and this is 2. So if I have the right point, this should equal this. Well, not quite. It's 13.1 equals 12. Get as carefully as I make that graph. I'm really disappointed it's not closer than that, but so be it. So I think the 0.25 is a little too much. And I think the 3.7 is a little too much. Let's see how it works out in the second equation. So you get 5 times 3.7. If these are off, it's probably going to be a bigger error up here, minus 4 times 0.25 equals 18. Now, 5 times 3.7 is 18.5, if I get my arithmetic right, minus 2. That should equal 18. It's actually 16.5 equals 18. So these are close. So we expect the actual solution of these equations, which we're going to proceed to do here in a minute. So we expect actual solution close to x equals 3.7, y equals 0.25. All right. Now you got to be able to do this. In the first place, you need to be able, having already done the assignment and graphing equations with intercepts, you need to kind of lock that in. And everybody's close. Some of you have nailed it. And you also need to, so you're going to graph both of them on the same set of coordinate axes. You're not going to tell where they cross. And you have to understand that the equation, any numbers that satisfy this equation are going to have to lie on the straight line I've depicted here. And all the numbers that satisfy this equation lie on this. So the numbers that satisfy both equations have to be right here. That's important to understand. Gives you a much better understanding of the meaning of graph. Okay, so now we're going to actually solve these equations. There are a number of methods that we can use to solve equations. going to do an actual solution by substitution. And the way that works is, first step, solve one of the equations for x or y. Your choice of which equation and which variable. I don't see a big advantage of one over the other. I'm just going to solve the first equation for y. But if you want to solve the second equation for x, second equation for y, or the first equation for x, that would be fine. Any choice is a good choice. If the numbers look like it's going to be nicer if you do it one way rather than the other, then do it that way. Okay, so first equation, actually, I'm going to, I'm going to solve first equation for y. Okay. Okay. I'm going to solve first equation for y. We get 3x plus 8y equals 12. Now I'm going to not get too hung up on the steps, but make sure your algebra is up to doing this, right? Okay. So I've explained the algebra a number of times. We solve linear equations. You should be pretty good at solving linear equations by now, and this should give you no trouble. But anyhow, we subtract 3x to both sides. We get 3x plus 8y minus 3x equals 12 minus 3x. And 3x minus 3x gives us 0, so we get 8y equals 12 minus 3x. So we divide both sides by 8. And we get y equals, I'm going to say 12 over 8 minus 3x over 8. Or y equals negative 3/8 x plus 3/2. Just putting it in slope intercept form. Now, does that make sense? You know, we've got a graph. Let's see if that makes sense. That the first equation should have a slope of negative 3/8. Well, there it is. It's kind of a small slope, right? It's not 0, that'd be horizontal. But a slope of 1 would make a 45-degree angle with the axes. That looks like pretty reasonable 3/8. And the y-intercept should be 3/2. This is y equals mx plus b. M is negative 3/8. Makes sense. Going down, not a big slope. And y-intercept 3/2. Well, that's what the y-intercept is. So we're pretty sure we solved that correctly. Okay, well, we plug this solution for y into the second equation. Okay. So second step. Plug the variable, which I'll abbreviate DBL. We solve for into the second equation. Or the other equation, because you might have solved the second equation into the other equation. So the other equation is 5x minus 4y equals 18. Now, you're going to plug the variable, okay, wish I restated that, but I'm going to just stick with it. Plug variable solve. Well, that means you solve for y, right? I'm not going to plug y in here because that wouldn't change anything, right? But y equals negative 3h plus 3 halves. So what I really meant up here, well as I'd like, I think it's pretty clear. This goes in here. So the other equation is this. Here's our solution. We plug this expression in here. We get x minus 4 times negative 3h x plus 3 halves equals 18. Well, now that's a straightforward equation to solve. The first thing I'm going to do is I'm going to use the distributive law here. I get 5x minus 4 times negative 3h x minus 4 times 3 halves equals 18. Just distributing multiplication by negative 4. Everybody should be good with that. Because you use distributive law in solving a lot of the linear equations we saw earlier. Okay. And then through the magic of fractions, I'm not going to go through the details, but well, yeah, I guess I am. You're going to get 5x plus 12h minus 12 halves equals 18. You know how to multiply fractions. You'll understand 4 over 1 times this, 4 times this, 1 times this gives you 12 over 8. And negative 4 times 3 over 1 times 2 gives you negative 12 over 2. Okay, so we've got a discussion going on. Let's stop and make sure we're on track. Okay, good. So the question came up is just, when you got this, how do you get in slope intercept form and what? You just reverse these, reduce the fractions, and there's your slope intercept. Slope intercept form could be y equals b plus mx. Doesn't matter which order they're in, but usually we do mx plus b because that's kind of standard. That's easier to read. Okay? Wouldn't be wrong if you did, in this case, like the b and the mx. Okay, well, anyhow. We say that we can plug this into this equation. This is what we get. And we just do the arithmetic and we get down to here. And I'm still going to do a little more arithmetic because I want to simplify my fractions as much as possible. And now I want to multiply through by my common denominator, which is 2. Okay. I could have multiplied through by common denominator up here, but since everything's since you have a distributive law here, that gets a little complicated. So you kind of want to do your distributive law first. Having done that, you see that, well, when we multiply these out, the fractions reduce. And now this gives us something pretty simple. So we multiply both sides by 2. I could add the 6 to both sides. I probably do, but I'm going to say, as soon as you see it in this form with distinct terms and denominators, get rid of the denominators, and then it's going to be real easy to solve. So I'm going to multiply by 2. Get this. Pretty clear. I mean, every term's written down with a 2 in front of it. And 2 times 5x is clearly 10x. 2 times 3 halves. Well, I'm going to do it. It's like 2 over 1 times 3 halves, right? And 2 times 3 is going to give me 6 over 2. And if you're not sure, do this. Maybe write it out. 2 over 1 times 3 over 2. So it's 2 times 3 over 1 times 2. Use the basic rule because that's secure. Even if it takes you a little longer. I'm giving you enough time on tests. There's no time limit. But it's got to be done by the time we close. Okay? And if you start early in the morning, hopefully you'll be done well before we close. Okay. That's not going to be that long. So you should be able to handle that. Okay, well, anyhow, here we have it. Now, but that gives us 10x plus 3x minus 6 equals 18. And we just add 6 to both sides. We're going to add the 10x to the 3x. Then we're going to add 6 to both sides. It's going to give me 13x equals 24. So that x equals 24/13. And that's really disturbing because from my graph, I know that x was about 3.7, right? Go back to my graph and I say, okay, I really screwed something up. Anybody see what I screwed up? I'm going to pause for a second. There's an auto screw up too. Okay, now obviously I did something wrong because either my graph is wrong because my graph predicted an x coordinate of 3.7 and 24/13 is less than 2. That's 2 times 13 is 26, right? Okay. So I know that this number is way too low, so I look back up here and see, and I say, oh, wait, that was a 12 and a 36, not a 6 and an 18 like it was back here. Okay? So I've got to correct that. So we'll just do that right here before your very eyes. Yeah, I'm not sure. That'll just 2. Let's see if I can get it. Okay, so let me get this down correctly. Negative 12 equals 36. So now I get 13x, 10x and 3x. I've got the minus 12, but I really want to get rid of it. And the only way I can get rid of it is to add it to both sides. And now I get 13x equals 48. Okay? So that x equals 48 over 13. Now, 48 over 13 is pretty close to 3.7. Now, I'm not going to use the 3.7, but that really agrees pretty darn well with my estimate. So it must be my 0.25 that's off, but I'm still having a problem seeing how that's going to reconcile. And honestly, I do see a problem, but I don't see how the graph could be off by that. Okay, well, what do we do now to find the y coordinate? Okay, third step. Plug this value into the into the equation. To solve in step 1. Okay, that's probably on the right step. Well, the equation we solved in step 1 was the second equation, and that's the first equation. So we've got this equation. We're going to plug in x equals 48/13. So Some of you that like to work with fractions are going to be happy. The rest of you still will. And at least trust us. We really want an exact solution. Okay. So we're going to get 3. Going to get us then 3 times 48 per case plus 8y equals 12. Well, 3 times 48 is 144. Multiply everything by 13. Gets to be a bit of a mess. Well, you know, the numbers are getting kind of big. You get 144 plus 13 times 8 is 104. And let's hope I did the arithmetic correctly. And this is 156. I'm kind of double checking my arithmetic. I think that's probably right. Well, I'll write this here. We get, I don't want to write out the step because I either have to write small or overlap too close to these equations. But you can trust me, I hope, to subtract 144 from 156, right? So I subtract 144 from both sides, and I get 104y equals 12. So that skipping the step, that's about 12 over 104. Okay. And that's about 0.12. Now, if I use 3.7 and 0.12 over here, 0.12 would be about 1. I'd have 11.1 plus 1, which would be very close to 12.1. Now, if I use the exact numbers, because 3.7 isn't exact, 0.12 here isn't exact, okay? But it's very plausible then that the exact numbers would be equal. I expect they would be. Now down here, I get my 18.5. Then I'm going to subtract 0.12, that's like a half. Okay, if that 0.25 reduces down to a 0.12, that's going to give me something pretty close to a half. So I'm going to have like 18.5 minus a half, which is going to be 18, right? Now I have to do the exact fractions and they get a little ugly. You know, the denominator of 104. Well, we can reduce that. That would be 3 over 26. Okay. So we have to plug in 3 over 26 here. That is 0.25. And 48 over 13 here. Now 26 is a multiple of 13, so you come to denominator to 26. It wouldn't be that bad. You still probably end up using the calculator. Okay. The point is, the process is simple enough. We've got a little detail with the numbers. That shouldn't give you a problem at this point. If it does, probably good that you deal with it a little bit. But the idea was we just solve one equation for x or y. So I solved this equation for y. I got this expression. And I plugged that expression back into the other equation. Here. Well, that's what we did up here. Plug this expression into the second equation. And then I just did the arithmetic, okay? And the arithmetic is not terribly bad, but got some fractions to deal with. So. So that's a second step. Then the third step is you just plug that value back into whatever equation you used here, and you get your y value. And we find here that x is 14/8, 13, x is 48/13, and y is 3/26. So it's chalk, kind of hard to write with. So I'm getting really bad 48. I think that's root error. Okay, well, that's a 48. Looks like a deformed snowman, but 48, okay? Meaning, if I could graph this with complete accuracy, this point so the actual crossing point would be this. And in decimal form, that is about 3.7.12. I have room to write that in. You can compare that with 3.7.25 and see that wasn't too bad of an estimate. Okay. This line came out just a little high. And this line came out just a little high. See, this line kind of curves up, and this line has a little wobble in it. Okay, now we did have a comment. So I wouldn't choose to use substitution. Okay? Neither would I. Not for linear equations. But substitution is an important process because if you don't have a linear equation, it's usually your only option. So you got to know how substitution works, and you got to do some problems using substitutions. Please, when you do the problems in the substitution section, use substitution. You also have to understand the graph, understand the geometry of this thing. Now, what we didn't get to go over, and I might rearrange the assignments, or I might just let you turn you loose on it, is parallel and perpendicular lines. Okay, and I think I'm just going to rearrange the order of some of the assignments to not have to need to do that, because you do need some work on this. You need to concentrate on this right now. Okay, so we do have some slack in the schedule. I've got to use a little bit of it. Okay, let me pause this.